Download this code from codegive.com, link in the description below. Resolving Git merge conflicts, a beginner's guide. Merge conflicts are a common and sometimes intimidating part of using Git. They arise when Git can't automatically figure out how to combine changes from different branches into a single, consistent version of your code. This tutorial will walk you through understanding why merge conflicts happen, how to identify them, and, most importantly, how to resolve them effectively. We'll cover the basics, common scenarios, and best practices to help you confidently navigate merge conflicts and keep your Git workflow smooth. 1. Understanding the fundamentals, branches and merging. Before diving into conflicts, let's refresh our understanding of branches and merging in Git. Branches. A branch in Git is essentially a pointer to a specific commit in your repository's history. It allows you to develop new features, fix bugs, or experiment with code in isolation from the main code base, often called the main or master branch. Think of it as a parallel timeline of development. Merging is the process of combining changes from one branch, the source branch, into another branch, the target branch. Git attempts to automatically integrate these changes. 2. Why merge conflicts occur. Merge conflicts arise when Git encounters overlapping changes between the source and target branches on the same lines of the same file. Specifically, conflicting lines. The same lines have been modified differently on both branches. Overlapping modifications. The changes touch the same regions of a file. Ambiguity. Git can't determine which changes to keep or how to combine them automatically. Imagine this scenario. 1. You create a branch named feature/new button from main. 2. On the feature/new button branch, you change the text on a button in index.html from submit to send. 3. Meanwhile, on the main branch, another developer changes the same button's text from submit to confirm. 4. When you try to merge feature/new button into main, Git will flag a conflict because it doesn't know whether to use send or confirm for the button's text. 3. Identifying merge conflicts. Git provides clear indicators when a merge conflict occurs. During Git merge. If you attempt to merge and a conflict arises, Git will stop the merging process and display a message like Git status. Running Git status will show you a list of files with merge conflicts. This output tells you which files contain conflicts. 4. Examining the conflict markers. The most crucial step is to open the conflicted file, S, in your text editor. Git inserts special conflict markers within the file to highlight the conflicting sections. Let's break down these markers. Head marks the beginning of the changes from the current branch, the branch you are merging into, in this case main. Head is a special pointer that usually refers to the last commit of your current branch. Separates the changes from the current branch and the incoming branch. Feature/new button marks the end of the changes from the incoming branch, the branch you are merging from, in this case feature/new button. The name after usually indicates the branch where these changes originated. 5. Resolving the conflict. This is the core of the process. You need to manually edit the conflicted file, decide which changes to keep, combine them, or create a completely new version that satisfies both sides. Here are the general steps. 1. Understand the changes. Carefully examine the conflicting sections and understand what each branch was trying to accomplish. Look at the context surrounding the conflict to see how the changes fit into the overall code. Talk to your colleagues if you are unsure what one side intended. To choose a resolution strategy *, there are several approaches you can take. * Keep one side * delete the conflict markers and keep the changes from either head, current branch, or the incoming branch. * Combine the changes * integrate the relevant parts of both changes into a single, coherent solution. This often involves rewriting the code or adjusting it to work with the changes from both sides. Write new code * discard both sets of changes and write new code that achieves the desired functionality. This is often the best solution if the original changes are incompatible or no longer relevant. 3. Edit the file * open the file in a text editor and manually resolve the conflict. This involves removing the conflict markers, *, modifying the code to reflect your chosen resolution strategy. 4. Test thoroughly * after resolving the conflict, it's crucial to test your changes thoroughly. Ensure that the code works as expected and that the changes haven't introduced any new bugs. Run unit tests, integration tests, and perform manual testing to confirm the code's stability. Example *. Let's revisit our index.html example. Scenario 1, keeping the main branches change, confirm. You would edit the file to look like this. Scenario 2, keeping the feature / new button branches change, send. You would edit the file to look like this. Scenario 3, combining the changes, example making it configurable. Let's assume your code allows the button text to be configured via a variable. You would edit the file and related code, example a JavaScript file or configuration file, to incorporate the feature branch changes in a way that works with the main branch changes. The HTML file might look something like this. And you'd need to update the configuration, or write logic to decide on the default. Scenario 4, choosing a completely new message, example submit. 6. Staging and committing the resolved file, s. Once you've resolved all conflicts in a file, you need to stage and commit the changes. 1. Stage the resolved file * use git add to stage the resolved file. 2. Commit the changes * create a commit to finalize the merge. Git will automatically create a merge commit message. You can edit this message to provide more context about the conflict resolution. 7. Aborting a merge. If you find yourself in a situation where you cannot resolve the merge conflicts or you want to start over, you can abort the merge using. This command will reset your branch to the state it was in before the merge attempt. It will discard any changes you made while trying to resolve conflicts. Use this with caution, as you'll lose your partially resolved changes. 8. Common scenarios and advanced techniques. Binary files conflicts in binary files, images, executables, etc., are usually not resolvable by manually editing the file. You'll typically have to choose one version or the other using git checkout ours file or git checkout theirs file before staging and committing. In these cases, communication with your team to determine which version is appropriate is essential. Ignoring wit space changes sometimes, conflicts arise due to wit space differences. You can use the W flag with git diff to ignore wit space when identifying conflicts, git diff W. Some text editors and IDEs have settings to automatically ignore wit space differences as well. Using a merge tool for complex conflicts, using a dedicated merge tool can be extremely helpful. Git can be configured to use a visual merge tool like Meld, kdiff3, or Beyond Compare. These tools provide a three-way view of the conflicting files, allowing you to easily compare and combine changes visually. To configure a merge tool, The git merge tool command will open the conflicted file in your configured merge tool. The merge tool allows you to visually compare and resolve the conflicts. After resolving the conflicts in the merge tool, save the file and close the tool. Git will then automatically stage the resolved file. Pull requests and code reviews. Using pull requests and code reviews is a best practice to prevent merge conflicts and ensure code quality. Reviewers can identify potential conflicts early and provide feedback on how to resolve them. 9. Best practices for avoiding merge conflicts. While merge conflicts are unavoidable in collaborative development, you can minimize their frequency and complexity by following these best practices. Keep your branches short-lived. Small, focused branches that are merged frequently are less likely to have conflicts. Long-lived branches tend to diverge significantly from the main branch, increasing the chances of conflicts. Pull frequently. Regularly pull changes from the remote repository to keep your local branches up to date. This helps to integrate changes early and avoid large, conflicting merges later on. Communicate with your team. Coordinate with your team members on who is working on what parts of the code base. This helps to avoid overlapping changes and reduces the risk of conflicts. Consider using feature toggles. Feature toggles allow you to release new features in a controlled manner without directly modifying the main code base. This reduces the risk of conflicts and allows you to test features in production before making them available to all users. Understand your team's branching strategy. Make sure you clearly understand the team's branching strategy. Knowing whether features are integrated daily, weekly, etc. will guide you to integrate your changes at the appropriate time. 10. Code example, a practical scenario. Let's demonstrate a practical merge conflict using git commands. Summary. Merge conflicts are a natural part of Git collaboration. By understanding the underlying principles, identifying conflicts accurately, and applying effective resolution strategies, you can navigate them with confidence and maintain a clean and consistent code base. Remember to communicate with your team, keep your branches short-lived, and use the tools available to streamline the conflict resolution process. Practice these techniques, and you'll quickly become proficient at resolving merge conflicts like a pro. Good luck.